Okay, we're doing homework today from Unit 5, Lesson 5, page 223, numbers 1 to 3a, b, and c, 4, 8, and 9a. So let's start here with number 1. Look at our book on page 223, right over here. And it says, if the statement is always true, write A. If it is sometimes true, write S. And if it's never true, write N. So question 1, part A is, a square is a rhombus. Is that always true, sometimes true, or never true? So is a square always a rhombus? And so for that we're going to say always true, because every square which has 4 right angles is also going to be a rhombus which has equal sides and not 4 right angles. So square is a more descriptive form of a rhombus. So every single square will indeed be a rhombus because they're all the same length each side and each corner is a right angle. Good. So that's always true. Question B says, a rhombus is always a square. Now that's not true. That's going to be sometimes true, because if we look at our picture back up here, this rhombus is not a square. Although I could have a rhombus that also is a square, depending if it has right angles or not. A rhombus doesn't require right angles, while a square does. Okay? Part C, it says a kite is a parallelogram. And that could be true. Actually, it could not be true, right? If we have a kite, let's say we have a kite that has these two sides are congruent and these two sides are congruent, but it happens to be that all 4 sides are congruent and both sides are parallel. That could be true. So that's going to be sometimes true. But you could have kites that look like this, which are not, where we have this and that, but these lines aren't parallel, and we need opposite sides to be parallel, where they could be here, but they can't be here. So not every kite is a parallelogram. Question D asks, a rectangle is a polygon. That's always going to be true, because no matter how you draw a rectangle, it's going to have the features of a polygon. Each vertex brings 2 sides together. There's no openings, overlaps, curved edges. Every rectangle is indeed a polygon. Question E asks, a polygon has the same number of vertices as sides. And that's also always going to be true, no matter how you draw a polygon, because each side will meet at a vertex. So let's count these sides again. Our sides are 1, 2, 3, 4, 5, 6, 7, 8, 9. And our angles starting from here are 1, 2, 3, 4, 5, 6, 7, 8, 9. And because 2 sides can always meet only 2 sides for each vertex, you'll have the same amount. So we'll say always true that all polygons have the same number of sides and angles. Question F asks, a parallelogram has 3 diagonals. So that can never be true, because if I drew a parallelogram, it has exactly 2 diagonals. Right? So we'll say this is never true. G asks, the final one, a trapezoid has 3 bases. So again, this can never be true. If I draw a trapezoid will always have exactly 2 bases, here and here. There we go. And so it can never have 3 bases. So that was question number 1. Let's see question number 2 now. In our book, turn the page to 224. It says, in an isosceles trapezoid shown, ST is parallel to RV. And so here, again, these are our parallel sides, and it's an isosceles trapezoid, so I know the 2 legs must be congruent. We want to here name the bases, the legs, the lower base angles, upper base angles. Okay, great. So the bases are this top one ST and the bottom one RV. Those are called the 2 bases of my isosceles triangle. So let's label those ST and RV. That's part A. Part B wants to know the diagonals. Name the diagonals. The diagonals are those lines that go diagonally across from opposite vertices. So our diagonals are SV and RT. SV and RT. Okay. C wants to know the legs. So the legs are the ones that extend between the bases, SR and TV. SR and TV. Okay, D wants to know the lower base angles. So the lower base angles are here on the bottom, this angle and that angle, we call it SRV and TVR. So angle SRV and angle TVR. Okay, and E wants to know the upper base angles. Those are those two on top. We call those SRT and VTS. Angle RST and angle VTS. RST and VTS. Okay, and now question F wants to know all pairs of congruent alternate interior angles. So we get alternate interior angles when we have two parallel lines. This one is parallel to that one. That's true of any isosceles trapezoid. And so the alternate interior angles are this one with that one. So TSV with SVR. And then the following one over here, here's another transversal across. And we'll have that's an alternate interior angle with that one. Remember, it makes this Z shape. And that's VRT and RTS. So let's write those down. So we have two pairs. Pair 1 is, we said, TSV, angle TSV, and angle, TSV and SVR. And our second one is angle STR, with angle TRV. Okay, that was question 2. Question 3, we're going to do parts A through C. The first part A is GEF a polygon. So GEF is this little triangle here, GEF, and indeed triangles are polygons, so we can say yes. Question B is A, B, C, D, E, F, G, E a polygon. So we walk ourselves around this polygon, starting at A, B, C, D, E, F, G. So far it is a polygon, but now I go back to E. Now I have three sides coming to one vertex, and that is not going to be a polygon. So I can say no, because we can't have three sides coming in one vertex in a polygon. And question C is A, G, E, D, C, B a polygon, and that's this hexagon on the outside. That is a polygon. So let's say yes. Okay, now question 4. It says, judging by the appearance of each figure, give the most descriptive name. So over here, A looks like all sides are the same length, and it looks like all sides are right angles as well. All angles are right angles, so I could call that a square. So A is a square. Okay, B, here we see we have opposite sides look to be congruent, and they look to be parallel as well, but no right angles. So I'd call that a parallelogram. Parallelogram. Okay. Now C over here, we have two sides that are parallel, and opposite sides, these are the legs, which are seemingly not congruent. So we would call this a trapezoid, with only two sides are parallel, and opposite sides not congruent. It's a trapezoid. Okay. D over here looks to be a circle. E is a rectangle. We have all right angles, and opposite sides are parallel, but not all four sides are congruent. So it's a rectangle. F, I have opposite sides parallel and opposite sides congruent, but I don't have right angles. So this would be a rhombus. Seemingly all four sides are congruent, just like another parallelogram, which doesn't have all four sides congruent. A rhombus does. G. G looks to be a kite because I have adjacent sides are congruent, but not all four sides are congruent. So that's a kite. H looks to be a triangle. And I looks like a isosceles trapezoid, because again I have a trapezoid, the opposite sides are parallel, these aren't, but they appear to be the same length, so we'll call that a isosceles trapezoid. Isosceles trapezoid. Okay, that was question 4. Let's move on to now 8 and 9a. Question 8 starts over here on page 225. It says here, given A, B, C, D is a kite, and we have the measures of each of the sides. We want to solve for x and y. So let's draw this picture out here, and we'll label our sides. There's a kite, and it says AB. Well, let's put the letters on. A, B, C, D. AB is x plus 3, and BC is x plus 4, and CD is 2x minus 1, and AD is 3x minus y. So that's what your picture would look like. And now I want to first solve for x and y, so the only one that uses y is AD. We'll do that one last. But I do know these two sides, CD and BC, must be the same, where I can avoid using this side with the y, so I'm going to set 2x plus 1, 2x minus 1 rather, equal to x plus 4, because I know on a kite the two adjacent sides must be congruent. So I can write my equation 2x minus 1 equals x plus 4. Now we need to get the x's together, so let's subtract x from both sides. 2x minus x is just 1x, so x minus 1 equals 4. Then I can add 1 to both sides, and I'll get x equals 5. Great, so now I know x is 5, and now I have to solve for y. The way I'm going to do that is I can say now that AD and AB are congruent, so 3x minus y is equal to x plus 3. And I know that x is 5 from over here, so I can go ahead and plug that in here and here. Let's go ahead and do that. 3 times 5 minus y is equal to 5 plus 3. And 3 times 5 is 15. 15 minus y equals 5 plus 3, which is 8. Now I can subtract 15 from both sides. I get negative y equals 8 minus 15, which is negative 7. Multiply both sides by negative 1, I get y equals positive 7. So now part A, I've found my x and y value. And now I have to go ahead and part B says, what is the perimeter of the kite? So let's plug in each of our values. So if x is 3, x is 5, so 5 plus 3, this side is 8. 5 plus 4, this side is 9. 2x minus 1, right, it should be the same as the other one. 2 times 5 is 10, minus 1 is 9. Wonderful. And 3 times 5, 3 times x, 3 times 5 is 15, minus 7 is 8. And it works out well. We see our two adjacent sides are congruent. Two adjacent sides are congruent. I can add these up. 8 plus 9 is 17, plus another 17 is 34. That's my perimeter. And question C asks, is it possible for AC to be 19 units long? Why or why not? It's possible for AC to be 19 units long, so AC would be a line down the middle, and I want that to be 19 units long. So maybe remember from our triangle inequality that if I have three sides of a triangle, and this one here is 19, the other two, x and y, have to be greater than 19. X plus y must be greater than 19, because if it's not, they won't reach all the way across. So if I add my x and y here, my 8 and 9, I get only 17. So if these two sides are 17, that's not enough to make a 19 diagonal. So we'll say no, it is not possible. Okay, and our last one is 9a. It says PQRS is a kite and also a rectangle. What else do we know about PQRS? So let's take a look at that one. Let's draw a picture that's a kite and a rectangle. So a rectangle, we know, looks like this. It has 4 right angles and opposite sides congruent. But what I know about a kite is that a kite needs adjacent sides congruent. So if this is 2 ticks, this one also has to be 2 ticks. So these two are the same, and these two must be the same. So now if I have all 4 sides congruent, because the opposite sides must be congruent and the adjacent sides must be congruent for it to be a rectangle and a kite, with our right angles here, we know this must be also a square. Okay, and that concludes our homework for today.